Hello everybody, this is going over electromagnetic waves, the homework. It's not too long, 3 pages, but they were pretty simple. Over here you've got a picture of an electromagnetic wave, where you've got an electrical wave going up and down, and a magnetic one going in and out of the page. That's kind of like taking a little positive charge and shaking it up and down, and that makes the electric field go up and down like that. That creates a magnetic field that goes left and right. So it's got north pointing one way, then north pointing the other way, and north pointing left, and north pointing right, and back and forth. Anyway, first thing was 3 examples of electromagnetic waves. All of these are electromagnetic waves: gamma rays, X-rays, ultraviolet, light, infrared, microwaves, and radio waves. So, next thing is, check all applies. Electromagnetic waves can be caused by the vibration of charged particles. So, it's got to be charged particles. We're getting into that. Electrons and protons. Neutrons have no charge to them, so they're not going to give you an electromagnetic wave. Let's take a look down here. As a wavelength of an electromagnetic wave increases its energy, well, the energy of an electromagnetic wave is directly or proportional to its frequency. It's actually equal to a constant, Planck's constant, times the frequency. Now, because your wavelength is inversely proportional to your frequency, that means your energy is going to be inversely proportional wavelength. Long wavelengths are low energy. Short wavelengths are high energy. So, as the wavelength increases, its energy will decrease. The range for visible light is between 400 and 700 nanometers. Pretty straightforward on that. Flip the page over. What differentiates a mechanical wave from an electromagnetic wave? There are 2 things. One is that the mechanical wave needs a medium. Needs some physical material to go through: air, water, the ground, steel, whatever it is. It needs some material. Electromagnetic will go through a vacuum. Doesn't need any medium. The other thing that they didn't mention is speed. A mechanical wave is always going to be less than c, which is the speed of light. While electromagnetic waves are going to be moving at c, 3 times 10 to the 8th meters per second. Circle the responses that make the statement true. Sound is an example of a sound moves stuff. It's a mechanical wave. And so it cannot travel through the vacuum of sound. There was a movie, Alien, saying nobody can hear you scream in space. And it was absolutely true. It's all from the 70s, late 70s. It's a great film, by the way. If you want to be scared out of your mind, it's a great film. Anyway, which of the following quantities could be used to describe electromagnetic waves? You can use its wavelength, frequency, energy, all of them you could use to describe what kind of wave it is. And a packet of energy, electromagnetic energy, is called a photon. Now, I'm actually going to add something else to that. It's also referred to as a quantum. But photon is what they mentioned inside the reading that you had. Now, we've got our electromagnetic spectrum here, and it lays everything out. You've got gamma, X-rays. You can tell they cross over here. Those frequencies or wavelengths have properties of both. There's only a little sliver that's only X-rays, and then you've got a band here where it's got properties of both X-rays and ultraviolet. Then ultraviolet, this little band here is visible light, infrared, microwaves, and radio waves going on forever and ever. Now, this is a logarithmic scale, and here's what I'm going to show you. I got to take the phone off of here to show you. But that's a log scale. And what that means is if I've got 1 all the way over here, notice everything's getting compressed. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so this is equal to 10. Then it's 20, 30, 40, 50, 60, 70, 80, 90, 100. 200, 300, 400, 500, 600, 700, 800, 900, and finally 1,000. Notice 3 is pretty close to being in the middle between 10 or 30, between 10 and 100. 3 is in the middle here between those two. 3 is pretty much in the center of these. This, on your reference table, is also a logarithmic scale. So let's talk about it. Get this set up here so it's not too confusing. Good. So you don't have all the divisions in here. Now keep in mind, over here, your wavelengths are getting longer. Going this way, you're getting higher frequencies. Okay, and then they took this little band, it's not the scale, but gave you the gave you the frequencies. These are all frequencies down at the bottom for light. Okay, so which electromagnetic wave has the highest frequency? Well, frequency's got longer in this direction, it's got to be gamma. Which has the greatest wavelength? Wavelengths got longer as you went this way. It's actually radio waves. Long radio waves, you want to be more specific, but he said radio. That's totally cool. Which electromagnetic wave has the greatest energy? Now remember, the energy is proportional to the frequency, which means the higher frequency gives you the most energy, which means it's got to be high frequency, it's gamma. What electromagnetic wave has a wavelength of 3 times 10 to the negative 6 meters? All right, let's take a look at here. Here's 10 to the negative 5th. Here's 10 to the negative 6th. This is getting longer here. So 1 would be right about here. 1 times 10 to the negative 6th. 2 would be right about there. 3 times 10 to the negative 6th is right in the middle because it's getting bigger going this way. And that clearly falls into the infrared section. What has a frequency of 1 times 10 to the 1st to the 7th hertz? 1 times 10 to the 7th hertz is right down here. And that is 1 times 10 to the 7th. That's radio waves. Last but not least, what color does a human eye perceive with photons of 4.9 times 10 to the 14th hertz enter the eye? 4.9 times 10 to the 14th hertz is between 4.82 and 5.03. So that means you will see orange light. All right, everybody. I hope that helps you out. Made sense. It's not super tough on this so far. Okay, you take care. Enjoy your Memorial Day weekend. Okay, I didn't want to give you work over that weekend. I think I managed to avoid that. And I'll see you guys on next Wednesday. All right, take care now. Bye-bye.